Good morning and welcome everybody, whoever is attending my lecture series on anesthesia workstations. Now I am starting my lecture. Traditionally, a needle valve controls the flow of individual gases into the flow meter. Needle valve has a relatively small orifice with a long tapered conical seat. As the control knob is turned on, the plunger is retracted and gases flow between the seat and the plunger. Since it takes many turns of the fine threaded screw to retract the plunger, precise regulation on the flow rate is possible. In order to avoid damage to the seat, preventing the stem from disengaging from the body, there are stops at the off and maximum flow positions. The control knobs are labeled clearly, color-coded and touch-coded. The oxygen control knob is larger, protrude further from the meter assembly and has fluted profile. The actual flow is measured by the cylindrical tubes with varying internal diameter. These are known as thought tube. As per Hazen-Poiseuille equation, the laminar flow through the tubes is directed proportionally to the pressure difference across the both ends, fourth power of radius, and is indirectly proportional to the length of the tube and the viscosity. As far as the flow through the orifice is concerned, the flow is turbulent and is directly proportional to the square root of the pressure difference across the orifice, square of the radius, and indirectly proportional to the square root of the density. The flow meters on a machine are traditionally called rotameters, a trade name adopted by the British Oxygen Company. They are variable orifice, fixed pressure difference devices. As the flow increases, the rotating bobbin raises in the flow meter and the annular orifice around the cylindrical bobbin increases. The calibration is either etched on the flow meter or written immediately to the right of the tube. One reads the flow at the top of the cylindrical bobbin, and the center of the spherical bobbin. At low flows, the bobbin is laminar and viscosity influences the flow. Whereas at high flows, the flow is turbulent and density influences the flow. At low flows, the flow meters are calibrated as milliliter per min or in decimal fraction of liter per minute, whereas at high flows they are calibrated in liter per minute in order to facilitate the accuracy at the low flows. There may be two tubes used to measure the flows for a single gas. One tube measures up to 1 liter per minute and the high flows are measured in the second tube. However, there is only one control knob and the flow meter tubes are connected in series. Flow tubes are equipped with the float stops at the top and bottom of the tube. The upper stop prevents the float from ascending to the top of the tube and flooding the outlet. It also ensures that the float is visible at maximum flows instead of being hidden in the manifold. The bottom float stop provides a central foundation for the indicator when the flow control valve is turned off. Traditionally, in a flow meter assembly, the oxygen is located upstream due to the fact that the Boyle, inventor of the Boyle apparatus, is left-handed. This arrangement has a potential to deliver hypoxic mixture if a leak develops in other flow meters. Hence, the most modern machines, the oxygen flow meter joins downstream of all the flow meters in the same machine. The arrangement is not changed externally, but oxygen joins downstream due to presence of appropriate baffles inside the flow meter assembly. However, the damage to the oxygen flow meter will result in the hypoxic mixture if nitrous oxide is also being used. Continuous monitoring of the inspired oxygen concentration with the associated alarms if hypoxic mixture is being delivered is the only opinion to ensure that a hypoxic mixture is not delivered to the patient. Now we come to the thank you. I now come to the end of my lecture series for today. I will come with more information in my next lecture series. Thank you.